Is it possible to write a unique structural formula for dichloroethene if we are told that the molecule is non-polar? Dichloroethene has three different possibilities that I can think of as regards the possible structure. Okay, so ethene has two carbons connected by a double bond. We learned that earlier. So if you think about this, there are cis positions. These two positions would be cis to one another, and this would be cis if there's a chlorine here and a chlorine here and a hydrogen here and a hydrogen here. This would be cis 1,2 dichloroethene. Another possibility is trans. We keep this chlorine here and this chlorine up here. Now, that is trans dichloroethene. The other possibility is to put both chlorines on one carbon. And that would make the other carbon have both hydrogens. That is called 1,1 dichloroethene. And that's all the possibilities I could think of. Now, in order to determine whether these things are polar or not, we need to look at the polarity of the bonds and how they're arranged. Now, I'm going to draw polar arrows based on things that we've already learned. And that will show that the two carbon-chlorine bonds are polar towards the chlorine, and the two carbon-hydrogen bonds are slightly polar towards the carbon. The net vector from those vectors is a vector pointing down towards the side of the molecule where the chlorines are. So that cis 1,2 dichloroethene is polar. Questions on that? Okay, now if we look at trans 1,2 dichloroethene, the two carbon-chlorine bonds are polar, but they balance one another. This one goes in this direction, that one goes in that direction. They're the same size, and they balance one another out. Same thing for the CH bonds. They balance one another out. So this one is nonpolar. Okay, if we look at the 1,1 dichloro, the bond vectors look like this. And so there'll be a net vector that goes in this direction. So 1,1 dichloro will be polar. So if we're told the molecule is nonpolar, that does narrow it down to the trans possibility. That's